Today, we have a fantastic opportunity to explore the world of DevOps with one of the industry's leading experts. But before we jump into the heart of our discussion, allow me to introduce our esteemed speaker, Nagaraj. Nagaraj brings over 22 years of rich experience in DevOps practices, specializing in Azure and AWS. He's not just a DevOps SME, he's a testing automation architect and a quality engineering leader. His expertise cover a vast array of areas including DevOps practices, test automation architecture, and quality engineering leadership. So without further delay, let's give a warm virtual welcome to Nagaraj. Welcome, Nagaraj. I hope you are having a great day.
Thank you so far. It's a one of a kind experience that I had. Thanks for the opportunity once again. Let's begin and welcome everyone once again. Today's topic is ABC of DevOps, key practices and methodologies. And thanks for taking time out of your busy schedules for attending this talk. I hope you will go back enriched and excited about this wonderful field of DevOps. I think I can quickly skip this slide because you've already been introduced. But a quick glance, I've played multiple roles in dev, QA, management, and leadership, and been a practitioner specialized in Azure and AWS DevOps technologies. I am a Cisco certified DevNet expert and an avid educator with a passion for imparting knowledge in the areas of DevOps, network automation, cloud computing, and so on. Normally, I stayed away from certifications, but I chanced upon this wonderful field of network automation. And I also happened to give it and happened to clear it. So this, I would say, this is my first serious certification in my entire career. Okay, let's start with the usuals. Let's get the usuals out of the way so that we can see more exciting stuff. I'm sure all of you will be knowing what is DevOps, but let me take you through this anyway once again. I would like to quote Microsoft here, which defines DevOps as a portmanteau coined by combining the words development, dev from development, and ops from the operations. DevOps is the union of people, processes, and technology to continually provide value to the customer. Whoever defines it, you will see just the variations of these definitions in some way or other. But these are the key points that come out in everyone's definitions. That is people, processes, technology, right? The what of the DevOps is always people, processes, and technology. Why is to provide value to the customers, right? We are bringing these three disjoint pieces, right? That is the people, processes, and technology towards achieving the ultimate objective of providing value to our customers. Any organization would work towards it. Its sustenance depends on what is the value that they bring to their customers, right? So these are the key pillars that aid in this journey. Now, how the value to the customers can be defined, right? In terms of faster delivery, in terms of better quality, in terms of better efficiency, in terms of better security, which in turn results in overall customer satisfaction. That's what we would say it's a value addition, right? We don't want to delay our releases. In fact, if we can get to them before the promised date, obviously we have added much more value. Deliver to them with a much better quality than they were expecting, much better efficiency of the product, secure product. All this obviously would result in overall satisfaction of the customer. Okay. Now, in some way, these things we have been talking about when we were defining agile methodologies also, right? Agile is primarily customer-centric. We have the Agile Manifesto, Agile Principles, which talk so much about customer, 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 right? So um, is DevOps an extension of Agile? Is it an evaluation on top of Agile processes? Or is it a missing piece in the whole game of this Agile? We can say that DevOps is an effort to take the innovations of the Agile approach and apply them to operational processes. Agile was focusing more on the development side, and it has certain best practices. Now we take these best practices, combine the operation side of the things so that we get a better end-to-end flow. Yes, I'm sure you'll be getting the recorded session. Okay. So who are the people involved in this entire process? It is primarily, and what is the challenge that is faced currently? That there was a need to come up with this term, to change the way that things are working, uh, to change the way we are doing things currently. And what are the challenges that necessitated this entire paradigm shift? Right? It is primarily the developers who are too busy worrying about meeting the deadlines, finishing the current release, and moving on to the next release, building something and just throw it over the wall for the operation teams to worry about, right? And operation teams on the other side, we have the operations team, who are primarily responsible for deployment and ensuring that the product is up and running, the customers are able to use it. They're too busy worrying about stability and reliability of the build, sometimes even at the cost of delaying the releases. So these two teams are working in silos, are working disjointly, each of them trying to achieve their own objectives, which was hurting it, right? This was leading to the famous wall of confusion, right? If you have been reading about DevOps, you would have heard about this term, wall of confusion. Now, what is this great wall of confusion? On one side of the wall, we have the developers whose primary objective is speed. How quickly they can solve the customer's problems, how quickly they can innovate and build new products, how frequently they can deploy, how frequently they can roll out the changes. That's what they're eating, breathing, right? And on the other side, we have operations who are primarily worried about stability. They want to maximize the uptime. They want to minimize the failures. They want to meet compliance obligations and maintain security. Okay. So what is the way out of this confusion? Okay. So to find a way out of this, the organizations have to follow a three-pillared approach. First, they have to change the culture. Second, they have to adopt the technological innovations. Third, they need to take a relook at their processes. On the culture side, they have to adopt the culture at the organization level to do what is required to reap the benefits of DevOps, to provide value to the customer. They need to enable the people, motivate them, and trust them to get their job done. On the technology side, we have to adopt automation, which is a key success factor of DevOps success. Key factor for DevOps success. right? We need to start with an automation first outlook. We need to automate, and then automate some more. If you see in the entire life cycle, as we are going to see, any piece which is manual obviously is going to hurt the advantage that DevOps will bring to the table, right? So we have to try and automate everything. And if you look at the array of tools that are available in the market, there's no dearth of tools that are out there. But choosing the right tool for the right job is still a challenge. And so that's where the innovation, experimentation comes into picture. And on the processes side, right, the organization should ensure that they should not let the processes get in the way of experimentation and innovation. Streamline approvals, remove unwanted delays, and enable customer feedbacks, loops, so on. In essence, what the organizations have to do is break down the silos that the teams are working on, bring people and teams together with a single objective of bringing value to the customer. Realign their processes, work towards this objective. Adopt the tools which are required to achieve this objective. And the wall is broken. Both the circles have joined with each other to form an infinite loop, right? DevOps is aptly represented by this infinite symbol because it is a journey. It is a continuous journey where we continuously do things, keep improving ourselves, keep innovating, keep providing more and more value to the customers. Okay, so if you look at this entire on the left side of this symbol, right, we have the core development activities, that is planning and coding, building, and testing. Then earlier they used to be partly involved in releases, right? They used to probably give a script using which the release would be created. But now they are part of this seamless process. They are part of this entire process. So the release, after that, the operation cycle starts. Deploy, operate, monitor, take the feedback back to the developers, so that which in turn releases in the next set of planning, and the cycle continues. Okay. On the code side, we have crucial pieces like source code, version control, right? On the building side, we have development tools and automation. Then on the testing side, also we need to have like we normally talk about, when we talk about DevOps, right? We talk about CI/CD, but what we don't talk about, and which is very crucial for the success of this, is CT, right? Continuous testing, right? What is the value that brings it? We'll see. Now, moving on to the release, we have this usual processes of CI/CD, continuous integration and continuous development, delivery and deployment. Okay. On the deployment side, we have principles coming into picture, like you have automated provisioning of infrastructure services using the principles like infrastructure as code and configuration management. And on the operation side, we have virtualization, containerization, which is aiding faster deployments, better management of the deployed software. And on the monitoring side, we have visualizations, logging, continuous monitoring. Okay. So when we think of DevOps, what comes to our mind usually is CI/CD, as I have already said it. And somewhere hidden in between this, CI/CD typically stands for continuous integration and continuous delivery or deployment. But why stop there? Why not start talking about continuous testing, which already is hidden somewhere in between CI/CD? And as you can see, continuous testing, which means fully automated testing, which is tightly coupled or integrated into your entire CI/CD process, is a key success factor for your DevOps lifecycle. Continuous provisioning, that is, as part of your DevOps journey, when the releases are ready to be deployed, you'll be needing multiple, you'll need to create multiple environments in a quick time, right? You need to set up dev environment, which probably would have been in place already, QA, staging, pre-prod, production, and so on. So if this piece is not automated, the provisioning of the servers, again, it's going to hurt. Then continuous configuration. After provisioning the servers, we need to configure them. They are not in a state for us to start deploying. That piece covers the continuous configuration. Then continuous containerization. There are different ways we can deploy applications, right? We have seen the traditional challenges of developers saying that yes, code is working on my system. That the tester says no, it's not working on my system. And some of the developer comes to the tester, he copies certain files and he makes it work. But when this code goes onto the pre-prod or the prod, it stops working. Right? We get into this endless life cycle. So to get rid of this, we adopted this principle of containerization. Right? Bundle everything that are required for a product into a container so that it works. If it works on dev system, it works on QA system, it works on pre-prod, it works on prod, it works anywhere. Okay. Then continuous orchestration. Now, deploying is one aspect, but how do you ensure that your application is up and running, performing, and it is meeting the customer's needs in terms of scaling up, scaling down? That's what is taken care in continuous orchestration. Finally, continuous monitoring. Unless you are able to monitor, measure something, unless that feedback is being given back to the developers, we will not be able to improve, right? So this is your, that's why I say continuous is the keyword there. We need to think in terms of everything continuous process, everything as a continuous process, right? Now, as a result of this, right, we started with CI/CD, continuous integration and continuous delivery and deployment. We will end up, when we follow all these processes rigorously, we will end up with CI/CD again, which means continuous improvement, continuous development, right? Organizations evolve, improve themselves continuously, and they develop, keep taking steps towards better customer satisfaction. Okay, so that's our ultimate goal, from CI/CD to CI/CD. That's the entire DevOps journey. Okay. Now, where does the cloud fit in into this scheme of things? If DevOps was the cake, cloud is like a cherry on the cake. That's because cloud makes DevOps even better. Right? We have seen that continuous integration, provisioning, configuration management, orchestration, containerization, etc. They are very, very challenging, very ambitious goals. But if your on-premise infrastructure is not able to support you in this ambition, in working towards these goals, in achieving this ambition, you're not going to succeed. So you need a highly efficient, highly scalable, which is available on demand, which is ready to meet your infrastructure needs at any point of time. Yet, on the cost side, you pay for what you use, which precisely is your cloud. Okay, cloud brings all these benefits to us. Cloud data centers, which can scale at the click of a button, and we can set up alerts to scale them down. And we have this principle of pay as you go. How much ever you use, that much you'll be paying for. Okay, that's how your cloud computing or the cloud can enhance your DevOps experience. Right? Imagine like your organization is starting a new project or scaling up a production application. And obviously, no organization will just keep hoarding the virtual machines or the servers on which these virtual machines will be created in their data centers, right? So they need to plan well in advance and procure the required servers, configure them, get them ready to be able to meet the deadlines. But uh, this time can drastically be reduced with cloud. Yeah. So cloud infrastructure comes with its dynamic provisioning and scaling capabilities, makes this entire process smooth. And you have the advantage of pay as you go. Cloud minimizes the latency, enables centralized management, right? All your resources you can manage through a single console. And a cloud platform allows DevOps teams to adapt to changing requirements, right? Like, let's say like you are Amazon, right? You have a flash sale coming up. Now, for that 1 hour, 2 hours, you need huge amount of computing power, huge number of servers, because you don't know how many people are going to come and hit your website. And after the flash sale is over, your capacity goes down, your hits go down, right? So if you don't scale when people are coming and hitting your website, you will be in trouble, right? Because people are going to see your application crashing. They'll not be able to log in. They'll not be able to make the purchases. Your sale will not succeed. And after your sale is over, people start leaving. You're back to your usual traffic. But what do you do with this enhanced resources? You just can't keep them sitting there, right? And keep incurring huge amount of cost. So whatever you made in flash sale will go in maintaining these resources. Of course, we are talking about AWS. They own the ERP e-commerce site. So they are the ones who is making the sale. They are the ones who are owning the infrastructure. So it's like from one pocket to the other. But still, it's like if you just can't keep up this infrastructure simply sitting there, right? So you should have a way to quickly bring it down, scale it down. So dynamically scale up and scale down. That is one of the primary advantages of that the cloud offers us. Okay, any questions so far before we get into what is the journey that the typical DevOps engineer would well, autoscale is primarily required. See, autoscale will be required in any industry. For example, it may not be at that drastic scale. Normally, we take this example because autoscale is required within a matter of hour. Right? That's the reason we always take this example, because to dramatize the things. Otherwise, like let's say in organizations, you have this what's that application? Um, they tie up with canteens in cafeterias in companies, some lunchbox or something, right? Now today they have tied up with one organization like let's say Deloitte, and they need to deploy, they need to support all Deloitte offices across. And tomorrow their sales team goes and manages to break a deal with another big organization like IBM. Overnight, right? From today, you are supplying, let's say 30,000 end users or employees of one company. From tomorrow, another client needs to be onboarded, which means your application should start supporting now all the IBM employees, because they will start downloading your application. They'll start using it to buy food in their respective cafeterias. Right? Typically, these are the kind of scenarios wherever you have your application needs are going up. Well, latency is not always on the installed application. It depends on multiple factors, right? Latency is in general the delays which are involved in setting up the entire stuff. In fact, cloud can also minimize the latency because uh, they have these alerts and monitoring mechanisms which are in place, uh, which keep monitoring your services. And as your services are undergoing stress, you can set up auto scale features to increase your capacity, which is not feasible with on-premise solutions. Right? Of course, there's a cost which is involved with it, but if you want to beat the latency, then you have to adapt it. Okay. So what is the typical journey that the DevOps engineer would need to take? It begins, I would say it begins with shell scripting, right? Because let's start with make a beginning with a humble beginnings. Why shell scripting would be required? Why it is an essential skill for DevOps engineers is DevOps is not simply about working on the procuring cloud environments, configuring, right? It's about solving your developers' day-to-day problems, uh, making your day-to-day work better, faster, efficient. So in this process, you might have to identify and automate your routine tasks, like uh, creating file systems, copying them onto the remote machines, creating users, etc., etc. And another important tool is later we are going to see, like uh, certain organization Git provides us a feature called as Git hooks, using which we can implement best practices while committing code. These Git hooks typically can be written in other languages, your like Python, Perl, but primarily they are written by default. They are written in uh, uh, shell scripting, right? Git provides us pre-written hooks which are written in shell scripting. So if you want to uh, take advantage of this, and if you want to enhance and support your development teams by streamlining their code commit practices, you need to know shell scripting. The next important piece is software version control, where Git is the undoubted leader nowadays, which happens to be a distributed version control systems, which is widely used in organizations. Right now, this needs to be mastered by DevOps engineers, because probably they need to help the developers to set up the repositories, create and manage the branches, handle releases from the repositories. Right. So typically your branching structure would look like this, where these tags are like your releases. So you have a main branch, which is supposed to be always intact. And then you have a development branch. And from there, where your active development is happening. From there, let's say a new feature branches, you are creating some custom features. So you might have to spawn new feature branches and then complete the complete the new feature development in them. Okay, so typically developers know to the extent, because they largely rely upon the plugins that come with their respective development environments. Eclipse has Git plugins. So they save the code, they just click a button, push it, it goes and sits in the repository. So typically developers do not get into the nitty-gritty details of what happens in the behind the scenes. What are the branches, how they are being handled, what are pull requests, approvals which are required. And so that's where the DevOps engineer's role comes into picture. Now, what are the cloud alternatives for this Git? We have Git, which is a local distributed version control system, and which suffices your local repository needs. but your local repository is still not good enough if your laptop crashes. So we'll be backing up our code onto hosted Git-based environments like GitHub, GitLab, which acts as a backup as also as a collaboration platform where your entire repository, entire project code is sitting. So you have players like GitHub, GitLab, Bitbucket, and the cloud alternatives are like you have Azure provides something called as Azure Repos. AWS provides AWS Code Commit. Right? As we're going to see at every step for every tool that we have on-premise tool or the open source tools, which are primarily most of the DevOps tools are primarily open source. We have cloud alternatives, which the large organizations can take advantage of. Okay, so on the Git side, on the version control side, we have Azure Repos, which is provided by Azure and AWS Code Commit. Well, normally we keep taking these two names because Azure and AWS, because these have been pretty stable. They have put a lot of effort, lot of thought into it to streamline this entire process to give an immersive experience without leaving the cloud. Right? Once you enter Azure, you can get your everything done, entire life cycle done. Same is the case with AWS. Right? So that's why we keep taking these names. Whereas others are still reaching there. And VMware is coming up with their cloud solutions. Red Hat, OpenShift is coming up with their cloud solutions, but GCP also has already, but there are some missing pieces still. Okay, then comes the crux of the entire DevOps journey, the CI/CD, continuous integration, continuous delivery / deployment. Right? So continuous integration is the process of multiple developers being able to continuously push their code onto the main branch. You might say, okay, what's the big deal? They'll just push it. Right? Somehow pushing it is not the objective. Developers being able to continuously integrate their code into the main branch. Main branch has certain it has certain sanctity associated with it. The main branch is always supposed to have cleaner code from which at any point of time, if I choose to create a tag, attach a tag and create a release from it, I should be able to do that. Right? So we should maintain that sanctity. Now, if developers have to be in a position to push their changes that they are making on a daily basis or on an hourly basis, multiple times a day onto the main branch, they need to have proper pipeline setup called as CI pipeline, which means they make the changes, they push it into the development branch, then the test cases are automated, the unit test cases run, all the unit test cases should pass, then only it should go and they should be able to raise a pull request to pull their code into the main repository. Okay, so only then we'll say yes, they have achieved CI. Now, once they have achieved CI, then yes, now they have pushed their code onto the main branch. Main branch is clean, but can we create a build from that main branch and deliver it to the customer with confidence? We can do it only if tests are automated. CT. Your integration test should have been automated. Your regression tests should have been automated. Your system end-to-end test should be automated. Even your user acceptance tests should be automated. Only then, with confidence, we'll be able to deliver the build. So when you have CI established, plus all these testing pieces are automated, we have achieved CD1, as you can say, continuous delivery. And after this, if you also automate the last piece, user acceptance test, and also automate the deployment, directly taking the build and deploying onto, let's say, application servers like Apache Tomcat, JBoss, WebLogic, etc. You have achieved CD2. continuous deployment as well. Okay. Some of the popular CI/CD tools are Jenkins. You keep hearing these words. Jenkins by default, the name comes to our mind. But slowly others are catching up. We keep hearing Travis CI nowadays, Circle CI nowadays. And cloud alternatives, we have Azure pipelines, AWS pipelines. As I said, they have covered the entire spectrum. So, in fact, almost all these version control systems, hosted version control systems, have their own CI/CD in some way or other. GitHub has something called as GitHub Actions. GitLab has GitLab CI/CD pipeline. Azure has Azure pipelines. AWS has AWS pipelines. But still, Jenkins rules, primarily because it has been there for a while. It is quite efficient. It has very open architecture with plug and play kind of systems. There are thousands of plugins which have already been developed. Right? You name it, they have a plugin for that. Plus, above all, it's open source. So Jenkins is an open source automation server. It helps to automate parts of the software development by okay. The crucial pieces of building, testing, and deploying are automated. And this facilitates continuous integration and continuous delivery. So a Jenkins build contains configuration for automating specific task or a step in application building process. What do you mean by building software is? Basically, you need to, let's say you're working on a Java application, you need to invoke some command to compile your code, and then another command to create the jar, create the artifact, right? So Jenkins build jobs essentially provide you these elements using which you can choose those commands to build your create your builds. Now there are a lot of other things. Broadly, there are two types of projects that you can create: freestyle projects and pipelines. As the name suggests, freestyle projects, they can be used for quick tasks. Pipelines, like you can stitch together multiple stages of your build process. And pipelines have certain advantages, like they are more robust. They can recover from failures. Right? Pipeline is nothing but it consists of different stages. We can define different stages. Okay, this is my code checkout stage. This is my build stage. This is my test stage. This is my deploy stage. And let's say after code checkout and build, my pipeline fails. Then I have an option of recovering the pipeline from where it has failed. I don't have to start all over again. And let's say the pipeline is running and there's a network failure or a power failure where the server suddenly goes down. The pipeline can recover and start from where it has left. Right? We call the pipelines as durable. They are durable and they can withstand unexpected failures. So that's why pipelines are like preferred way of working. This is our typical pipeline looks like. Right? It starts with this keyword pipeline. Agent is like where the build will be running. Now, typically agents, we can use them as hosted agents, which means the server where Jenkins is installed, that itself can be used, or you can use your own VM where you have installed Docker. Then these are the stages, right? You have your different stages, and in each stage you have different steps. Now, the syntax that you see here is neither JSON nor anything. It is called as Jenkins' own DSL. And DSL stands for domain specific language. So nowadays this is becoming very common. Most of the software offer their own syntax, which anyway in some way or other looks like JSON. Typically the key value pairs or objects, but they give it a name, DSL, domain specific language. Okay, so this is Jenkins domain specific language. Okay, this we have already seen. The cloud alternatives are Azure pipelines and AWS code pipelines. Okay, now developers have completed the developing, then we help them to create the pipelines. The pipelines have run, the release is ready. What do you do with that release? It needs to be deployed. If it has to be deployed, the servers have to be provisioned or procured or created, right? That is what is taken care in this piece called as continuous provisioning. Behind the success of continuous provisioning is the IAC, the term called as IAC, infrastructure as code. Right? Infrastructure as code is the key principle behind success of continuous provisioning. It is the process of managing and provisioning the computer data center resources, to go by the official definition. IAC is the process of managing and provisioning computer data center resources through machine readable definition files. In simple terms, it means that we write code to create servers. Infrastructure as code. We write code to provision or create servers. How? Sorry. Okay. We'll see how it is done in a moment. And IAC makes much more sense in cloud than on-premise because of the dynamic nature of the cloud. Right? You have a script, you just run the script. Cloud has resources which it can just pull it out and give it to you on demand. And whereas if you are doing the same on-premise, there are a little more complications which are involved. You need to see which server has sufficient resources and so on. Okay? These challenges are not there on cloud. Some ISC tools are AWS CloudFormation, Google Cloud Deployment Manager, HashiCorp Terraform, and Microsoft Azure Resource Manager. Okay. Out of all this, obviously, again, the open source tools win. Not primarily because they are open source, because they are also powerful enough. Right? HashiCorp Terraform is a very, very powerful, very versatile tool, and which is currently is a kind of leader in IAC market, infrastructure as a code market. This is the Terraform architecture looks like. As I said, infrastructure as code. We write code to create servers. So we put some instructions in Terraform files called as manifest files, which have an extension .tf, which says that it is Terraform. So here we give instructions, right? Typical Terraform code looks like this. Okay, we'll come to that. So we give some instructions, which is taken by your Terraform. Now here in this instructions, you put saying that I want to create a Azure VM. Now Terraform does not know how to go and talk to Azure, right? Who knows how best to talk to Azure? Azure guys, because they would have provided APIs, application programming interfaces, how to remotely interact with Azure, how to remotely create resources. Okay, those APIs are wrapped as plugins, and which have been kept with Terraform in their online registry. Terraform has an online registry where we have a concept called as providers. Providers are nothing but plugins which have been provided by different people who support their resources to be created through Terraform, who support the concept of infrastructure as code. Okay, if I have to create Azure guys should give me a provider for Terraform. If I have to create a VMware remotely through code, VMware has to give me a plugin. They have to put it on Terraform's online registry. So I make use of that resource and give instructions, what I want to create. Then Terraform will take care of the rest. This you are going to see throughout, right? We call this as declarative style of programming. You just declare what you want. You don't worry about, unlike in Python, where you have to worry about, should I use a for loop? Should I use a while loop? What is the logic that I'm going to write? Here, in these cases, we just declare, okay, I want this to be done. It is up to the tool how it figures out and gets the thing done. Okay? That is how Terraform works. So it has a concept of providers, which we have already discussed about. It has a concept of registry. It's an online portal where all these providers created by different vendors are uploaded. This script shows uh, creating an EC2 instance at a very simple instance. Of course, it won't be as simple as that because we need to provide certain authentication details, certain more specification, right? So, but yeah, a part of it, a part of the script, you can see it here. We are saying that this script main.tf should use provider called as AWS, right? Now this provider AWS is nothing but a plugin which is created by AWS guys. So this is like an intermediate between your AWS APIs, which will help you to create AWS resources remotely and from wherever you are invoking this Terraform script. Right? So you specify a provider, you specify where you want your resource to be located, and then you start defining your resource itself. What is the resource that you are trying to create? It's the resource, the type of the resource that you're going to create is AWS underscore instance, which is typically the EC2 instance. Now, when you're creating an EC2 instance, we need to specify what is the Amazon machine image. That is the template, whether it's a Windows server, whether it's an Ubuntu system, and so on. And what is the instance type, which means the size. What should be the RAM, what should be the hard disk, how many vCPU should be there. All that is defined by this T2 micro, right? T2 micro, T3 micro, etc., etc. Okay. So that's how Terraform manifest file would look. Again, what you see here is neither JSON nor any other language. This is known as HCL, HashiCorp's configuration language. Okay, again, it is their own DSL, domain specific language. HashiCorp also supports JSON, but people prefer to work with HCL. So you have cloud alternatives, ARM templates, and ARM cloud formation. Sorry, AWS cloud formation for the AWS world, ARM templates for the Azure world. Okay. Now my release is ready, my servers are ready, but the prerequisites might be missing. The servers have been provisioned. AWS EC2 instances or Azure virtual machines have been provisioned, created. But do they have the necessary things that are needed for my application to be hosted? That is where the configuration management, continuous configuration management, or the configuration management comes into picture. Configuration management is the process of maintaining the system, such as computer hardware and software, in a desired state. This is again like a declarative. You just declare what is your desired state. You say that I want this server to have latest version of Tomcat with the port changed to so and so, with the default port from 8080, it should be changed to so and so, with so and so users updated in the config files, and the system restarted. All this I'm specifying. Right? Typically, these are the things that we will be doing, right? We install Tomcat. If you are doing this manually, we install Tomcat. Let's say that by default, it takes the port 8080. Suppose I want to change the port to 8080. I need to go into one of the config files, change the port. Then I have to enable users so that they can log into the manager UI and upload their files. So I need to go and configure the users and users config files. All this I should be able to do through configuration management tools. Again, we specify this in a declarative language as a code. Then the tools will take care of it. Well, Terraform and Ansible are kind of they work with each other. It's not like one is the alternative of the other. Terraform is primarily for creating, provisioning. Ansible is more for configuring, right? Ansible cannot create resources. And Terraform, okay, it can do configuration to a certain extent, but it's not as powerful as Ansible in terms of configuration, right? Because Terraform basically does not have the tools required tools for that, right? If you have a specific problem, maybe we can look at it and then see like whether Terraform can solve that problem. Okay. Some well-known configuration tools are like Ansible, Chef, Puppet, Salt. Again, in these, when it comes to configuration management tools, right? It's like this. You have provisioned, let's say, 10 servers. If you are going to each server and doing the configuration, then it beats the purpose, right? It's not automated. So you should sit at you should sit in one machine. Through this remotely, you should be able to configure all other machines. So you have the concept of central node where Ansible is installed or any of these tools installed, master node. They go and connect to each of the nodes and do the configuration. That is how most of these tools work. Now, in this process, there are two types of architectures: agent-based and agentless based. Agent-based means master is sitting here. There are agents which need to be installed on each of the machines, which carry out tasks, which take instructions from the master, and they carry out the tasks. Obviously, this is a disadvantage, right? Because nobody would like an additional agent to be installed on their systems. Or let's say you are trying to configure network resources, which are like which have those primitive, not primitive, uh, 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 not so open operating systems like network operating systems. You cannot install any other tools there. So in such cases, agent-based architecture becomes a kind of a handicap. So that's where agentless architecture, which is adopted by Ansible, has an upper hand. Okay. So yeah, what we discussed. Ansible is an agentless tool, configuration management tool, which is primarily written in Python. Now, how Ansible is able to do different tasks? Again, it has concept of plugins or modules, right? There are for doing every task in Ansible uses something called as a module. Module is nothing but the plugin which actually goes and does the task for you. Right? Now these modules are nothing but Python programs. You can write modules in other programming languages also like C, but primarily they are written in Python. So Ansible modules are nothing but Python programs by default. There can be certain exceptions. Okay. So Ansible makes use of small Python programs called as modules to carry out various tasks on remote machines. This is how it works. Ansible is sitting on a management node. These are the hosts which I want to manage. Ansible uses a simple SSH connection to each of these devices. Then Ansible instructions are given in a script called as playbook. Playbook is nothing but like how you write programs in Python. Ansible program is called as playbook. It takes the playbook, which is nothing but instructions. It uses the inventory, which is nothing but a file which consists of all these host details. And it goes to each of those machines, establishes a connection via SSH, carries out the instructions which is provided in the playbook. This is how a playbook would look like. So we are specifying on which all hosts these instructions should be carried out. I'm giving a name like web servers. In my what is it called? In my inventory, I would have created a group, right? And then I specify some variables, and here my actual task begin. So task one, I give a name. I'm saying Git. Git is a module. So which means actually there's a program, there's a Python program called as Git, which takes these as arguments and passes it to some function inside that to carry out this task. Same way you have something like pip, right? There's a Python program which is written as pip. Command, there's a Python program which is written called as command, which takes these arguments, goes and executes the job. Okay. So this structure that you see is YAML, Y-A-M-L, right? YAML is a de facto standard for writing configuration scripts. YAML is becoming, it's widely used, unlike your DSLs used by different players. On the cloud alternatives, you have Azure Automation and AWS Cloud Automation. These are like alternative to Ansible. Now we spoke about YAML. It looks pretty much like JSON, right? If you see, this is JSON, where you need to have these curly braces, then all the keys. Ultimately, all these files, right? They are like data interchange formats. So that on the computer, two programs can exchange data with each other. They come as key value pairs because we need to send what the data means along with that, right? So these keys describe the data. The values are the actual data. Now, if you see JSON or XML, you have like huge overhead. You need to have curly braces. You need to have these keys need to be in quotes, etc., etc. YAML has simplified this. They said, okay, curly braces are not required. You don't need to put it in double quotes. So they have further simplified JSON. Okay. If you use this Ansible doc, which is a command line utility, which will provide you help about different Ansible modules and pass the module name command, you will get some help from Ansible doc utility. There you can see that where is this module called as command located. If you see inside this, somewhere inside the site packages, Ansible modules, you have a Python file called as command.py. Okay? When you give that command in your playbook, this is the file which is being invoked. And the file looks like this. Right? Some instructions which are given in Python, which go and get executed. That's what Ansible is all about. Now, why I brought up this point is Python is also essential for DevOps engineers, because let's say they're asked to enhance an existing Ansible module, or they're asked to write a new Ansible module, which is not there currently, which suffices their needs. So Python also should be one of the things that DevOps engineers should be knowing. Of course, you don't need to be as hardcore programmers as developers, Python developers, but you should be able to find your way around. Okay, in fact, you can see that from the popularity of Python, 36 to 38%, it is being used for DevOps related tasks. 51% data analysis, 45% web development. Next is your, so it is somewhere on par with your machine learning. And these are some of the libraries which are typically used for your regular day-to-day automation tasks using Python. Okay, then comes the okay, yeah, we have configured our server. Now it's time to think of deployment. Like you can go with the traditional deployment of dumping your Python executables or Java jar files, which will make your life difficult to scale. Again, we have the same problem, right? Something that runs here, it does not run in the other system. That's the very reason the containerization has come up. So Docker is that containerization tool. This picture depicts how Docker is different from your traditional virtualizations. In both, there is a virtualization layer. In VMs, you have the underlying infrastructure. On top of that, you have virtualization layer called as hypervisor, on which will let us create virtual machines, which are like segregation of physical resources. Then you go inside, you need to install your OS, you need to set up all your tools, etc., etc. On the other hand, on the Docker side, you have infrastructure, then you have host operating system. On top of that, you have this platform called as Docker, which supports the containers to be directly dropped. Containers are like self-contained applications, which means a container can come with its own OS, its own file system. Let's say I have a Java application. What is required for Java? JDK, JRE. What is required for JDK? Some underlying OS. So container for this application contains that OS, JDK, Java application, everything bundled together. It won't be so huge because it takes only what is required. So that's how you have this small containers which sit on top of Docker. Which configuration are going to be for any specific scenarios on usage of listed config tools? Well, it depends on what is the challenge, what is the requirement. Most of the tasks can be done by Ansible. For some reason, if you have any restriction, you cannot use Ansible and you are on cloud, you are supposed to use cloud tools only, you have other options. Otherwise, Ansible can take care of majority of your needs. And as I said, if something does not already exist in Ansible, you can always extend it by writing Python scripts. Okay, this is like your Docker architecture. Again, Docker has a online registry where the base containers have been uploaded. What do you mean by base containers? Let's say the operating systems. There's a container for Ubuntu. There's a container for different flavors of Linux. There's a container for network related stuff. Now, if I want to build my own container, first I need operating system. So I take that container, image, right? Now, when you talk about Docker, you keep hearing the terms like images and containers. These are like VM templates versus running VMs. VM template is like a static file, which just contains the definition of the VM. What is the operating system, kind of static state of the VM. Then from that static VM template, you can create a running VM. Same way, images are like static files, which reside on the registry. You pull those images to your local system where Docker is installed. You create running instances of those images, which are called as containers. Okay. So those images will have underlying operating system. On top of that, your prerequisite software like Python, Java installed, on top of which your code sits. Right? This example shows how we can containerize a Golang application. Right? Some developer has written a Golang application. Now, what he needs for Golang to run, there is already a container with Golang pre-installed. Now, for Golang to be pre-installed, it needs some operating system. So that Golang container also will have some operating system. So the OS files, the Golang files come with this Golang 1.0 alpha, which is an image which is sitting in Docker Hub. Then on top of that, he is creating one directory, which he intends to use as a work directory. Then from wherever he is running this file, he is copying everything from the current folder onto the work directory. Then he is running a couple of commands. And he is specifying what should be the entry point. When the container runs, which command should be executed. That's the entry point. Right? When I run a container, which command should be invoked. That's my entry point. So this is how a typical Docker file would look like. When we build it, it looks like this, an image which contains multiple layers. We just use this layered architecture to say that yes, at the bottommost you have the Golang layer. On top of that, you created a folder. On top of that, you copied some files. On top of that, you did some modification. On top of that, you set some executable as your starting point. So we just call them as layers, layered architecture. right? Actually, if you see, these are not actually layers, right? I would consider something as a layer only if I'm adding certain files or if I'm adding something on top of that in terms of files, right? But yeah, that's the way it is. When people talk about Docker's layered architecture, you have to go with that. Okay, now Docker is fine for you to create individual, like you have a web application, you can Dockerize it. You have an API, you can Dockerize it. You have a DB application, you can Dockerize it. But how do you put these three things together to get a complete end-to-end application? That is where Docker Compose, another tool based on Docker, comes into picture. Right? Docker Compose helps you to create multi-container applications. And Docker Compose will take care of establishing connections between these containers, enabling them to talk to each other, serving their any network related needs, or providing them with any volume storage related needs. All that will be taken care by Docker Compose. And with one single command, you can bring up your all the containers together, which make up this one application, or you can bring them down. Okay, that is Docker Compose. Okay. This is how a Docker file looks like. Docker file, the components which are involved in this Docker multi-container application, we call them as services. In this example, we have a DB service, we have an app service, we have a web service, right? Backend, middleware, and front end. Docker Compose takes it. Now DB is already readily available, so it directly takes the DB image and runs it to create a DB container. And this web and API, probably the developer has given Docker files. So it takes the Docker file, builds the container, builds the image, and then runs it. The container is ready. And web also, it does the same thing. It builds the image, runs it as a container. So your component is ready. And you see here some environment variables have been set. Where is your MySQL database? What is the name of your MySQL database? What is the MySQL root password? Now, these database details will be used by your application files. There, these environment variables would have been used. So Docker Compose is helping you to link your app with the DB. Same way, your web needs to be exposed on certain port. So that is specified here by your Docker Compose. So when this Docker Compose file is run, your application will be up and running, and your web application will be available on port 80, and your app is able to communicate with your backend database. My screen is not visible. Suddenly it stopped, or
No, it is visible. I think Anil specifically has an issue. I'll request Anil to please join again.
okay, thanks. How much more time we have?
We have at least 20-25 minutes, but
Okay.
in the meanwhile, I will like everyone to know that please stick around us. We are having amazing learning journey with Nagaraj. We have amazing 1,000 rupees Amazon vouchers waiting for you. Please stick around. I will tell you all about it by the end of the talk.
Okay. So this is another Docker Compose example where a WordPress application can be built by anyone free of cost, simply using by building a Docker file like this. These Docker files are available on GitHub. You can build your own application if you have a place to host it. Right? So it consists of DB and WordPress website. Here the WordPress DB, the WordPress and DB are being linked through these database nodes. Okay. Now, alternatives to Docker are cloud alternatives to Docker are Azure Container Registry, Amazon's Elastic Container Registry, right? ACR and ECR. Now, they provide these container registry, but they don't have their own containers, right? So we again have to build our own containers and push them there, or download from the Docker Hub and push them there. Okay, now we have our containerized application ready, but the benefit of when we'll be able to take advantage of this containerized applications is when we have someone who will help us run this application, which means in an automated fashion. If I want to scale my application, he should take care of it. If I want to scale down my application, he should take care of it. If some of my containers go down, he should create more containers. That's what is precisely orchestration, container orchestration. Right? Container orchestration is another crucial part of CI/CD pipeline in DevOps. It's used to manage, deploy, and scale and provide networking to containers. Needless to say, Kubernetes is the leader in this space. There is one more called as Docker Swarm, but I was just seeing the other day. I'm not sure if I can find that joke. I think it's been reused. It's a joke going around in the DevOps circles. So there's a battlefield. There are two soldiers from the winning side, and all the losing side soldiers are like lying down. But these guys suspect that yeah, there are some people who are alive, but they are acting as dead. So one soldier is asking the other soldier, how do we know if there are any soldiers who are alive? So one guy says, Kubernetes or Docker Swarm. Immediately all the live soldiers, they start shouting Kubernetes, Kubernetes. And they go and kill each of them. So it just goes on to show that, yes, how popular Kubernetes is. Docker Swarm has made a humble beginning, but it has a long way to go there. Okay. Now, the main concept behind Kubernetes is the cluster. Cluster is nothing but, now what we need for scaling our application is we need the base platform. The base platform, which means the computational resources, is provided by joining multiple machines together, forming a cluster. Right? Cluster is nothing but collection of nodes. Node is a Kubernetes term. It simply means that VM. Okay? Cluster is made up of nodes. Now, inside this node, I will be going and dropping my containers. So the logical units which contain your containers are called as pods, right? Pod, node, cluster, these are Kubernetes terminology. Now, if you want to imagine pod, right? You can imagine this, correct? On those scientific movies where people embark upon intergalactic travels, they have these hibernation pods. They just go and sleep in them, right? The pod has the complete life support system, like your oxygen, your nutrients, etc., etc. So you just go and lie down in that, you're taken care. Same way, pods get their underlying computational resources, networking, storage, etc., etc. Like pod has been created with all those support systems. So your container just need to go and sit inside a pod, and then it will be up and running. Okay. So this is like Kubernetes architecture. It is a concept of cluster. Cluster consists of nodes, right? Now there are some pieces like kubelet, kubeproxy, which are needed for taking care of your executional needs, operational needs. And on the control plane, you need a lot of things, like you need an API server because this entire communication happens through APIs. You need a scheduler because you need to manage your applications, bring up, bring down. If something goes down, automatically bring up, and so on. And you have a controller manager, like different components with well-defined roles. But the main concept is nodes and pods. Nodes are nothing but VMs, physical machines or virtual machines. Obviously, physical machines is not so flexible, so virtual machines, so that you can dynamically increase your cluster size as well. And each of those nodes are divided into pods. Inside pods, we drop our containers. Okay. Now this node is typically represented as a hexagonal shape because we like to compare our cluster with a beehive. Right? In beehive, the cells are like typically the hexagonal, so it's easy to put them together. So this hexagonal structure is node. Now node needs a small utility called as kubelet to take care of its execution. He's like the manager, state manager, and it needs Docker, obviously, because what we are putting inside the pods are containers. So you need some containerization platform to be sitting on each node. Then we have the pods, right? These pods have their own like IP addresses, and inside the pods you have your containers and probably the volumes, etc., etc. Volumes are like storage, which is associated with. Okay. Now, how do you define your deployment? How do you create a deployment in Kubernetes? Again, using YAML, right? This is how a typical deployment looks like. So here, what we are basically saying is Nginx is like a web server or a reverse proxy. On Docker Hub, you have a Nginx image. So I'm saying take Nginx image, give it a name called as Nginx application, create 3 replicas of my Nginx application, and give a name to this entire thing as Nginx deployment. Okay. Bottom up, going bottom up. Coming top down is I'm creating a Nginx deployment. In this Nginx deployment, I want to have 3 replicas, which means 3 pods running with Nginx web server running inside those pods. Okay. Now, which is the container which should be used to put in those pods? It is this. Okay. And it should be running on all those pods should be running on port 80. That is how you define a deployment, which is like a logical this thing on top of your so you run this file, your deployment gets created, then you need to expose the deployment. So you create a service to expose the deployment. You have cloud alternatives, Azure Kubernetes Service AKS, Amazon Elastic Kubernetes Service EKS, Red Hat OpenShift Enterprise Kubernetes Container Platform, and so on. The final piece is monitoring, continuous monitoring. Yeah, your Kubernetes is taking care of complete orchestration needs. Now you need to, it's time to monitor them, right? So that's where popular monitoring tools come into picture, like Nagios, Prometheus. Capacity planning on K8 environment is involves a lot of factors. It depends on like your application needs. You can define limits. How much of because how many containers can sit on a node? It depends on the node's capacity, node's physical capacity, and how much your containers are using. But we don't want these containers to be because Kubernetes has a free hand. It can go on increasing your resources or reducing your resources. So you can define your limits. Only limit it my container usage to this much. So that's how you go about doing the capacity planning. You don't want a certain, let's say, the web to hog up the space so that your DB doesn't get enough this thing. Can Kubernetes be used without cloud provider? Yes, pretty much. How difficult it is to set up on-premise? It's not much. It's just that the instructions which are given in the documentation are not very clear enough. You have to research, and there are some websites which provide pretty good documentation. and installation instructions. Okay, Nagios is one of the tools. Prometheus is another tool. Nagios can be used to monitor and provide alerting for your servers, network appliances like switches, applications and services. It's like it covers the entire structure, infrastructure monitoring as well as application monitoring. And it monitors and it can also send alerts. Prometheus is more of monitoring alert and alerting functionality for cloud native deployments, including Kubernetes. This is our typical Nagios monitoring dashboard will look like. Its UI is not so great, but it's quite a powerful tool. And Prometheus just collects the data. It does not have a visualization of its own. So we have to take help of another visualization tool called as Grafana to be able to build dashboards using the data collected by Prometheus. So Prometheus more of a acts like a data provider. Cloud alternatives, we have Azure Monitor, Amazon CloudWatch. Okay, what next? After DevOps, what is the future? We have something called as DevSecOps. Right? We have achieved operational efficiency, development and operational efficiency with DevOps, but we are still lacking on the security side. So introduce security into the entire this pipeline process. That becomes your DevSecOps. Right from the beginning, there's a concept called shift left, right? For everything, we want to shift left. Testing, shift left. Quality assurance, shift left. Security, shift left. Automation, shift left. Right? Which means right from the beginning of the life cycle, you keep practicing these principles, DevOps security principles. Nagios can monitor K8s. It's more of applications and infrastructure management. I've not tried using this thing. I think the default tool to monitor K8 is Prometheus, but I'm not sure. Maybe there is a plugin. Nagios again uses concept of plugins called as NRPE. Nagios remote plugin executor is like a tool, and it has a bunch of plugins which are available. So probably if someone has developed a K8s monitoring plugin, we can pretty much use it. Okay, so DevSecOps. Then net DevOps, network DevOps, right? Because in the networking world, we keep coming across such statements. Every time we implement a network change, something goes wrong. The network is too critical to upgrade. They are scared to touch the networking, even to take care of upgradation. Of course, once upon a time, software was like that. When we were working with monolithic kind of applications, we have come a long way from there, but the networks have not still evolved. Though the software-defined networking is becoming more and more popular, these are the typical challenges that we face. So-and-so is on a vacation, and without him, we cannot make changes to the network. It's like the entire knowledge is centralized. Okay? That's where the network DevOps can make a change. Again, bring cultural changes, technical methodologies, strategies, and best practices of DevOps to the networking field. Orchestrate and automate network changes to reduce network delivery lifecycle. Treat network as a code and allow version controlling so that you have something to fall back. Okay, if this configuration is breaking your network, revert it back to the previous and then try it. Then we have MLOps, right? Machine learning operations. Now, so far, people have been working with machine learning models, but deploying machine learning models at a scale, on production scale, is still a challenge. Right? People are doing it, but again, that process is not well oiled, well refined. So that's where, again, adopting DevOps principles to machine learning, deploying, building and testing and creating builds and deploying machine learning models can bring this revolutionary change. So MLOps is one of the hottest fields now. Then AI Ops, right? Adopting AI principles into your DevOps. And there are so many things like monitoring, some things that can go wrong. So there, your artificial intelligence tools can help you, right, to make some predictions, mitigate incidents, etc. Right? MLOps and AIOps is different. MLOps is the implementation of DevOps towards managing machine learning models. AIOps is adopting AI principles to make your DevOps more efficient. Okay. Now, people won't stop there. They even went to the extent of creating something called as ARCOps, architecture and operations. Right? It unites software architecture and IT operations, guarantees that architectural choices align with operational demands. Right? Now we have joined developers and operationals, so they are going one step ahead and bring architects also into picture, so that any operational challenges that architects will be aware of can be mitigated. Okay? So essentially, it's like opportunities are galore. We have with DevOps, we have opened a Pandora's box. Now, it's not a tool, it's not a specific technology, it's not a principle, right? It's a combination of best practices. And what are we saying? Change your mindset, bring people together, use tools. As long as you are doing this, the kind of problems that you can solve, any problem you can solve, isn't it? So what I see as a future is wherever we have a challenge, that ops is going to come. These are some just use cases. Netflix has close to 600 plus services in production. When I say services, microservices. They deploy 100 times a day, which means continuously changes are happening. 100 times per day, they deploy into production. Imagine the kind of efficiency that they must be having to be able to deploy 100 times a day into production. Not a joke, right? Uber, 1,000 plus services in production. Deploy several thousand times each week. WeChat, the Chinese application, has 3,000 plus services in production. Deploy 1,000 times a day. I wonder what are those changes? How many changes are? How can thousands of changes be there per day? That's a different thing, but they have that kind of efficiency. Yeah. Now, how Netflix does is Netflix has invested heavily in DevOps. Developers build, deploy, and operate their own server clusters. Right? That's the kind of automation they have done on the infrastructure side, so that developers can create their own clusters. And of course, they are held accountable when things go wrong. Right? Great power comes with great responsibility, the saying goes. Okay, this is a little insight into how Netflix manages things. Deployment at Netflix is completely automated. When a service needs to be deployed, service means like new feature, which is packaged as a service, needs to be deployed. The developer first pushes the code to a source code repository, which is your GitLab or GitHub, Bitbucket. The code push is picked up by Jenkins. So they also use Jenkins. So as soon as Jenkins has a concept of webhooks, as soon as something is pushed into a repository, Jenkins job can get triggered, which subsequently performs a build and produces an application package. Then a fresh VM image from AMI, Azure Amazon Machine Instance. Right? So they use AWS. A fresh VM image from AMI, Amazon Machine Instance, is produced based on the base image, which probably contains a Linux distribution and all the software which the Netflix needs to run. So base in cloud also you have the same concept. You have base images like plain Linux image. I can take that plain Linux image, install all the tools which I require on it. I can save that as a new AMI. Then next time when I create a VM from that new AMI, I get all my tools pre-installed. I get a VM with all my tools pre-installed. So that's what they're talking about. Take a fresh VM image, which is produced based on an image containing Linux distribution and a software that all the network servers run, including JVM, Tomcat, and possibly further customized by the team. And on top of this, the application package, which is created by Jenkins, is installed. From this, another AMI is created. Again, convert that into template. So when you take the template, you have your service with your new feature running. Simply take that and the developers will deploy it into the Kubernetes cluster. Okay? That is the kind of efficiency that they have achieved. Q&A. Hope I'm on time. Well, I have one more. Can I share my screen once again?
Oh, sorry.
Yeah.
Sure.
Yeah. So I was asked to come up with ABC of DevOps. So I thought, why stop with ABC? I went ahead and created my own A to Z of DevOps. Right? So you can take a look at this and probably can come up with your own A to Z of DevOps.
Oh, that looks really fun.
So most of them are like tools and technologies which are used in the DevOps world.
This is really fun. I like the audience to give a cheers. This is something we must be seeing for the first time.
Yeah.
Oh, I see so many cheers, so many
Thanks,
applauses.
guys.
You all can certainly watch this, see this again. It'll be on our edTalk page of our website of edForce. You'll be getting a link very shortly. Yeah, Nagaraj, anything else you would like to add?
That's all. Thank you.
Okay, let's jump into the Q&A.
Yeah.
I see a question. I think I don't know how many of them have been answered. Anil has a question. Can you give some references to example of usage of MLOps and AIOps in K8 world? K8's world.
I've not explored these things yet, but yes, as when I come across, I'll be posting probably on my LinkedIn, uh, create an article on my LinkedIn page. Okay, at the top of the chat, I see one question.
Oh,
In the
there's
triangle cost, quality, and time, if you are going to reduce time through DevOps, will it increase cost and quality? Not necessary. It all depends on planning, right? Bad planning can increase your cost and reduce the quality while uh, 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 reducing your time, right? So it is, as I said, you have tools, processes. Choosing the right tool for the right job will decide these outcomes, right? You have a architect who is smart enough to choose the right tool for the right job and have the right set of people. You can reduce the time, you can increase the quality while not having any impact on the cost.
That's great. Ladies and gentlemen, as we come to the end of our insightful journey through the world of DevOps, I want to extend my sincerest gratitude to each and every one of you for joining us today. Your active participation, thoughtful questions, and engaged presence has truly made this talk a success. Also, I want to express my heartfelt appreciation to our esteemed speaker, Mr. Nagaraj. Your expertise, passion, and willingness to share the knowledge has been invaluable. You have provided us with invaluable insight, inspirations, and practical strategies that we can implement in our own endeavors. Together, we have explored the fundamentals of DevOps, learned about the best practices, and gained a much deeper understanding of how we can optimize our workflows. But more importantly, we have come together as a community of learners, united in our quest of continuous improvement and excellence. The best part, which I felt, was the A to Z, quite literally, which you showed us for DevOps. As a part, as we part ways today, let's carry forward the lesson learned and continue to strive for excellence in respective fields. Thank you once again for your participation and look forward to paths crossing again in future Ed Talks. EdForce has Ed Talks every month, almost. Wishing you all a continued success and growth in your DevOps journey. Thanks a lot, Nagaraj. This is
Thank
amazing.
you. Thanks everyone.
So at edForce, we keep doing ed talks. We will be having one ed talk on BART next month very soon. Thank you all. Thanks a lot. Thanks, Nagaraj. Once again.
Thank you.
Be ready and be prepared to write a Google review. Follow us on social media and win your vouchers. Signing off.